Hello, everyone. So welcome back. So this afternoon, we continue our day with a slightly different program. So this morning, we touched some of the aspects about the system, the consortium, and the technology. So we had HP, and we have some NVIDIA people that have been talk about, the programming model, MPI, GPU, the tools, etc., etc. This afternoon, we want to do something slightly different. Ultimately, these resources is made available for the material science and the molecular modeling community in UK. And there are two type of people ultimately that will use these resources. There will be people that has to run their science, so they use applications that are already well established, or they are developing themselves, but they need to do production. And they're somehow already users of national facilities, but they want to move these on GPU. And then we have people that they might never actually approach this level, this type of system. So they want to actually get to these new capabilities, do more. And because of the presence of GPU, they want to understand how to do a leap in performance, add GPU capabilities, and by doing so, achieving more science. So rather than continue to just talk about the technology and teach about how to do GPU computing, we thought it was more interesting to invite a speaker from the community, both UK and non-UK, talking about some applications that are obviously in scope for material scientists and have been ported or are currently ported on GPU using various different techniques and various different approaches, because no single application is equal to other. I've been shamelessly invited people that come from the quantum chemistry community and then quantum Monte Carlo community, not from the molecular dynamic community, for mainly two reasons. A lot of MD code are already GPU accelerated, and they're already out there and used a lot worldwide. The quantum chemistry community has some big codes that have GPU acceleration, other that are getting there, and other that are newly developed that are already thinking how to add the GPU acceleration while they're also developing and growing the application almost from the ground up. So we have 5 speakers for different regions. We have Phil Asney from University of York, Stefan Mainz from NVIDIA, Matteo Talin-Meufer from ETH Zurich, Dimitar Pasha from King's College London, and Ye Luo from Argonne National Lab. Then we talk about these 5 applications, CASTEP, VASP, CP2K, Quasar, and QMC So I will soon give Phil, this is the order in the way we're going to be, just an order. We're going to have a break in between again, like this morning, for like, depend by the time, 20 minutes, 15 minutes, things like that. I ask each one of these speaker to try to cover in the presentation 2 main points. How this application was developed, so what choice they made, why they made those choices, and what kind of lesson learned and best practice, anything that they basically will be themselves able to suggest to other developers to actually move a code that it might be similar to those on GPU. Obviously, the majority of the audience here should know the physics. So maybe some of those will talk about the physics a little bit, because it's good to put in context the physics with the implementation and why certain choices have been made. But I guess we don't have to start from first principle with this community. We can move directly to the juicy part. So